Hey guys, it's Cassie here with Math OMG. Today we are going to be talking about parametric equations. I'm going to show you two different scenarios. The first just is x's, y's, and t's. The second contains trig functions. So let's look at this first one so we can get through these two examples fairly quickly. So a parametric equation just simply represents an equation that in this case has x's and y's and then a third variable t, which is the parameter. So how I like to think of it and how I tell my students, it's like, think of x as representing horizontal distance and y as vertical distance. So t would represent time. So the horizontal distance and the vertical distance are both dependent on time. But we can also create an equation that relates x and y and eliminate the parameter t or time. So this is how we do it. The first thing you want to recognize is that our variables are x. We have x equals, we have a y equals equation, and they're both with respect to t. So that's important so that we kind of have an idea of where we're going. Our mission when we try to eliminate a parameter, we always try and write it so that we can have an equation where it's y equals something with respect to x, if possible. That's sort of our end goal. And then our game plan for doing that, since we're trying to get something with respect to x, we solve for t in the x equation, so 1 minus 2t, and then once we have t, plug into y equation. So let me show you what that looks like. So I'm going to solve for t in x equals 1 minus 2t. So x equals 1 minus 2t. I'm going to subtract 1 on both sides. X minus 1 equals negative 2t. Divide by negative 2. Divide by negative 2. Now if I divide x by negative 2, I'm going to rewrite that as negative 1/2 x, which would be the same as x over negative 2. This is just an alternate way to write it. And then I'm going to divide this minus 1 by negative 2. So minus and negative is going to cancel out and make plus. And then 1 over 2 is still just 1/2. So now that I know what t is with respect to x, I can take this whole equation that is represented as t and plug it in to my other equation for y. So I'm going to say y equals 2 minus my t is negative 1/2 x plus 1/2. And then I just simplify. So I distribute the negative through. So I get 2 plus 1/2 x minus 1/2. And then I combine like terms. So 2 minus 1/2 is 1.5 or 3/2. So I get y equals 1/2 x plus 3/2, or I could have written it as 1.5. So all we did is we took our first equation with x's, we solved for t, and then we take that t and we plug it into the equation that contains y, and that now gives us a new equation. So our final equation is going to be y equals 1/2 x plus 3/2. And that was from taking these two equations and rewriting them as one equation by getting rid of the t's. Now the second scenario that you're going to come across is when there are trig functions. So again, it's x equals and y equals, and when you graph this in your graphing calculator, so in your graphing calculator you need to go to mode and turn on para or parametric, and then you just go into your y equals and you plot this and you plot this and you just make sure your intervals are correct. So when you graph this in your calculator, you should see that it makes a circle. And the only reason I graphed it first versus the other problem I didn't graph is because I just don't really know what to do with these sines and cosines. So I wanted to get an idea of what it looked like. So what I should observe is that these two equations together made a circle with radius 2. My mission is to create an equation. So create an equation that only contains x's and y's, no t's. Sometimes one of them might eliminate. You might not have an x or a y, but for the most part you're going to have both of them, and we're going to try and get rid of our t values. And then our game plan for doing this is to use our circle formula, which is x squared plus y squared equals r squared. So if we look at this equation, we have our x, so it's going to be x squared plus y squared equals, and our radius was 2, so 2 squared, so this equation would be x squared plus y squared equals 4. Now that probably seems like really easy and simple because we had a circle. If we had something other than a circle, then if we would divide by this value, hold on, let me not make that too confusing. So if we had something other than a circle, what you would do if it was like an ellipse or something not centered on 0, the best way to do that is to use this formula. So cosine squared x plus sine squared x equals 1. So you solve this equation for cosine, you solve this equation for sine, and you plug them in for sine and cosine. So what that would look like in this scenario, cosine here is going to be x over 2. So this would become x over 2 squared because you're squaring it. Sine here, if I solve for sine, I divide both sides by 2. So sine here would become y over 2, and then again it says to square sine, so we square this, equals 1. And again, this is a Pythagorean identity, so we can use this if we need it. So since this is a Pythagorean identity, I'm just plugging into that identity. So this becomes x squared over 4 plus y squared over 4, because I square x and square 2, equals 1. And then if I want to get rid of that denominator, I'd multiply everything by 4. So the 4's would cancel out the denominators, and I'd get x squared plus y squared, and then 1 times 4 would be 4. So that's like a different way to do it algebraically instead of just visually seeing it and knowing it's a circle and using the circle formula. So that's how we eliminate a parameter and make a graph of a parametric curve. This would be the graph of the parametric curve. That's just like the way we say the graph. So I hope that was helpful. If you have any questions, make sure to leave them in the comments. If you want to learn more about parametric equations or what's coming next, which is polar equations, make sure to subscribe to my channel. Thank you for watching. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math, click on my website link here.